Oh, it's quiet.
Feel better tomorrow.
See you later. I'm pretty sure. How you doing?
I feel so much better.
You sleep last night?
7 hours. I mean 7 whole hours.
You look more chipper this morning.
I tell you, I was so tired when I got home that I watched a nice cool bath, Benadryl, and I slow laid down on the sofa. It was like, okay, we're at 2 degrees. We're going at 2 degrees. And by the time I was vertical, it was not the nausea, okay? And I just said, just lay here and relax. I'm trying to sleep, just relax. Boom, out by 11 o'clock. And slept until my wife got up. So I was like, yes, thank you, God.
I just gotta have sleep.
And I think that's what it was. I was just so tired. But my appointment is tomorrow morning at 8 o'clock in the morning to have my Christmas tree aligned.
Find out the magic.
Well, I talked to Chester, and I called for the appointment. And after I talked to Chester, I called the same doctor that I was in, the same practice that Chester went to. And I talked to the lady. She said, "Well, the first one we have in Shelby is Monday afternoon." And I started crying, and I said, "I haven't slept in 3 nights. I can't wait another 5
She knew
nights."
she needed to move it up.
Yeah, and I said, I don't want to be that chronic patient. I said, but please be aware that I am almost debilitated. And she said, okay, but let me see if there's anything open that you give her other practices. I'm like, okay, fine. So they, Friday went and passed on me. I'm like, you can put me in Charlotte. I wouldn't care. Okay. So I'm going to be there, and Chester said that I was describing what exactly does he have?
Like what I remember him saying.
And he said that it's, and I Googled the crystal thing, and what it is it is like a chiropractic movement where they're slowly moving the head to get the crystal to go back into where it's supposed to be. And they also said that if that doesn't work, they typically told the body to
How's the camera moving this morning?
Oh, look, I haven't checked the speed with which we're going to be moving today.
It's all good. I'll wiggle the connector or something before we start.
Yeah, okay. It's
responsive. Okay.
It is not crazy responsive like yesterday, but better.
I've never known it to be
And it could be
ultra sensitive. It
could have been I was so tired that I was touching harder and longer for top. But
you had a delay yesterday.
I had a delay. Okay, so Dale's going to look for a work study to do this. I'll be there with only there, but we want somebody to start out to do this so that next semester, that's what we'll do. The second half of this.
The second half of this semester we start.
No, the second half of this class. This is how.
Oh, the second part of this class. You have the magic. You turn the lights on.
And I even walk in private learning. So so that way the work study can be
somebody that's sharp and reliable.
That's the whole thing. We get somebody who's reliable. And it can't be someone involved.
If you talk to Bill, it's going to be Amanda and found out the audio was better yesterday. Said he was going to call us. I'm thinking it was just for the fact that we didn't have anybody say anything yesterday before they said,
and I think what your recommendation of pulling the audio down here makes the auto buffering less sensitive, okay? And I think that would be one of the things that it's not like that visual thing we have on
Tuesday. It turns the mic up, but we got a lot of sound coming out of the speakers. They hear that as sound. The microphones turn down. It's harder to people up low at times on that. That's the problem. If you ever have a loud sound, like everybody laughs at one time, and it's not too loud now. It's slow down.
Slowly comes back up. And that's one reason why I'm going to put the fan on, right? Because that creates that background white
Here's
noise.
that run, that sound comes through more clearly than you.
Okay, because, you know, as a human, we speak out, but the sound system doesn't.
Some of it would.
Yes, I do all.
Because, yeah, that's absolutely. Yeah, I'm looking for it. We've got a family thing playing Saturday, so I'm looking forward to that.
Or
Did you talk with Amanda? Was the sound better there yesterday?
I tried to,
Well, that's okay. Yeah, yesterday was.
Can you hear me, Dale?
We can hear you.
Okay. Yes, the sound was definitely better yesterday, don't you guys think?
Yeah.
Yeah. Definitely better yesterday.
I think we just need to turn it on. It's all low up there.
no, it's on high right now. Hello? Davidson
Yes.
County?
Yep. We're here.
Okay, can you hear us okay?
Yeah, it sounds great.
Is there like a drumming sound in the background because we have a fan running?
No, I don't hear any fan.
If the sound gets wonky, let us know and we'll turn the fan off. Because the mics might pick up the fan in the background and just, it starts getting, that may be one of the things that's causing our fishbowl effect.
Was the
Okay.
sound better overall yesterday?
The sound seemed to be fine yesterday.
We have made some adjustments a little differently here on this end. And the fact that nobody said anything yesterday about not being able to hear, we figured it must be better.
We've checked the camera responsiveness, so maybe it won't be soon today, okay?
Okay.
I have a question. I saw your hand go up.
Oh, I was wondering how the tests are gonna work for us.
Brittany wants to know how the tests are going to work for us.
How the test is going to work for you? Well, I will email a copy to this cleaner and you'll take your test there while we're taking our tests here.
Yeah, you're gonna need like 3 of those notebooks.
I realized that the first day when my homework was like 7 pages. This will be my chapter 0 and chapter 1 notebook.
So Dale.
Adele just stepped out.
Oh, okay.
I'll let you know when he gets back.
Okay.
Yeah, it is unusual, though.
Next item, okay. Well,
Yeah, I slept, remember, this morning. No,
that was messed up.
So I woke up and there was yesterday, but I didn't come in. So I stopped it.
Okay, so it doesn't care.
Because I can't. It's like,
Where the
so I can
top and bottom. Wait, what? A hole is in the root and then the top and the bottom. So in this one, you have like X man here and X man right here. So that
There you go.
I got the email.
What, virtual nerd? Oh my god.
I was on there.
I've got questions. Okay. How and why do you use this?
What do you mean? This is just the function, like, if A was 1 and N was 2, then it would just be x squared.
Well, then why is there an n down there?
Because it's like numbers with different coefficients. So this would be a leading coefficient.
Okay.
And this would be your leading coefficient. So it's your term and the coefficient for that term.
Okay. And then why is it 0?
Because that would be a constant number with no variable. So like if it were x squared plus 2, then that would be your 2.
And there's just right here because it doesn't know how many terms you have.
Yeah.
Okay, and then here, why did you change it to,
We code all these questions out of last night's summary.
is that the same thing, just different variables?
Yeah, so I would just be any integer, zero, and any or
Okay. Okay, I got it.
Dale back?
Oh,
Dale, you
he's
back?
got the room.
Okay.
Okay, how would you use like this formula to reduce it? Would it just be like finding the, yeah, it says right here that if it's irreducible, yeah, so quadratic is irreducible because you can't write it
So
this.
basically that just means you can't factor it.
But you can factor quadratics.
Some you can.
Some you can, okay.
Yeah, they don't have.
I had a couple things to tell you, Dale. First, our bookstore is being a little bit ridiculous and decided that I don't know what's going on with this book, but we still have 5 students that don't have a book. And the bookstore said something about not ordering the books again, but my associate dean is working on getting the problem fixed. I don't know what's going on, but it's happening with a couple different classes.
So it's not us in particular, it's just bookstores have a problem.
Right. Apparently they can't find this edition, but I told them to just get the edition that I have, and it should be fine. So I don't know what's. But we're working on that. So for now, I'm just gonna keep copying what we have, and hope I've gotten them up through 0.
Hopefully that didn't just get recorded.
The other thing is, these guys that are in your class are all also in math club.
Yes.
And so this is going to really help them. This is going to be our first competition year. We're going to go to the math competition this year.
Fantastic. That's awesome.
Yeah.
So where is the math competition out there?
This year it's at Forsyth Tech. So really close, which makes it easy.
Yeah, that's just up the road. Great. So that normally does involve calculus on that kind of thing, right?
Yeah, there's 2 parts. There's a pre-calculus, like the beginning of the morning, and then calculus in the afternoon. But I think by the end of November, they'll be able to do both parts.
That's fantastic. Yeah, by November we'll be through all the differential calculus. We won't have not much differential calculus. That's it.
But yeah, I think they'll be good. At least to try it out for the first time.
That's awesome. We had a math club for a while, but lately we haven't had much interest.
ACM. What's that going to
Years ago, we had a class. We went down to Gainesville, Georgia, for a math competition.
Hey Dylan, are you still interested in going to Ireland?
Yes.
Yeah? There's going to be an info session soon.
Ireland? I'm for Ireland now.
Ireland, we want Ireland.
I'll go everywhere.
You definitely, it's open to community members, Dale.
Pardon me?
Yeah.
Open to community college members?
Ireland?
So yeah, our international group is leading 3 trips this year. One is to Ireland, which I'm assisting with, and I'm going to Ireland. The second one is to Rome, Greece. Greece and Italy. And then the third one's to Costa Rica.
What part of Ireland are you going to?
It's like the north of Ireland and then Northern Ireland.
It's great. I've been a couple of times. It is absolutely my favorite place to go.
Yeah, I'm pretty excited. And I'm recruiting, so if you want to go, Dale, I can get you some info.
Yeah, I've always wanted to go over to, I've never been. Ireland, Scotland, that whole area would be like going home, so to speak.
Has anyone talked to Has anyone seen Elise?
Well, it's 8:01. That's what I've been going.
Dropping. I thought we do that for breakfast. Yeah. That way, so I've watched this.
Did chemistry.
There's a plug-in right there. I mean, I don't know if it'll fit in there, but I think so.
The PhD.
Probably.
Yeah, I just wanted to make sure because she's still in the
Yeah.
You don't have to sit it on the floor.
I don't blame you.
Oh, the PA program.
Is it already 8?
Yeah.
Yeah.
So, Elise, is Elise here yet?
Louise?
No, Elise.
I haven't seen her in a while. Where's she been? Where's she at though?
Where's the room making me feel better about
Here, but not here?
No.
Oh, okay. So,
Rezo's backpack I see in the chair there.
Yeah, you need to switch seats, Reza. He can't see you in that chair.
but you get to keep all your points, so you're good on that.
Emily's not here yet either.
Wait, so if I press this button, does the thing still work?
Yeah. Do it. Bet. There it goes.
This is basically what he's seeing right now.
Okay.
Okay. Shh.
Oh, let's see, what I want to do is get some kind of indication of how you've done the homework on first 2 sections, section 1, section 2. So,
What?
Come again?
homework on section 1 and section 2. I want to kind of do something like credit, kind of grade, just. So, what I want to do is.
So I said the volume was working good yesterday, but now it seems like you're drowning again.
Oh, no, let me step back here. Maybe it's there's a desk already. Can you hear me better now?
Yeah, a little.
No?
Yeah.
Perfect. Is it better now?
Yes.
Okay, there is a desk line, Sam.
There's right there.
There. So I wanted to give some kind of credit for your effort on the first 2 sections of homework. Okay? And so what I want you to do is write a score on the top of your paper for me. So, and then I'm going to collect that. So 5 if you did everything. Even if it's not clear. Or if you tried most of it.
Oh, well, I guess I learned.
Probably turning this on. Just wait until he's.
See if you did about half.
What's the vote for?
2 if you did, let's say at least 25%. 1 if you.
I don't have all my stuff with me today.
0 if you didn't do it.
You saw my
So
stuff.
based on that, now, when I said did everything, that means, be careful here. So you don't have any blank question, like just copying down the question and saying, oh, I don't know how to do it and leaving it blank. Copying down the question, leaving it blank because I don't know how to do it. That doesn't count as having done it. Doing it means, okay, I didn't know how to do it, so I got help. I asked in class, I went to Khan Academy, I did something, and I got something down, even if it's wrong. So simply writing down the question is not doing it. Putting a question mark, saying, I don't know how to do this, is not doing it. You have to do more than acknowledge I don't know how to do it. More effort than that. So if you did everything, tried everything, put a 5 on it. I think most of you probably did put something down. If you didn't, if you left something blank and you didn't ever follow up and get help on it, you have to write a 4. Okay? So put something on there, and then I'm going to collect that and glance through it myself real quick. Amanda, would you be willing to do that for your students at DCCC?
Yep. Do I need to rip this out of my notebook?
I don't have point 1 and point 2 in there.
Raise your hand.
Like, ask him?
That's the only one that did. There was a question just now, as we're already trying to finish up our assignment. Which section was that, Joe? Section 2. Section 2 apparently asked for, and I didn't honestly do all those problems, but there was a problem that asked for a function that is both even and odd.
And number 5, if you get a 5, it's for
Anybody get an answer for that? Joe said he figured out one. How about DCC? Did y'all get one? Who? Someone raise your hand. I can alert them. Josh, you raise your hand. What did you come up with?
I'm not sure. This might be just, but I put f of x equals 0.
Yes, in fact, that absolutely does work because it's even because f of 1 is 0 and f of -1 is 0. So you're getting, plugging in a negative or a positive, you're getting the same output. But then how is it that it's off? I don't know what we mean by that. So, now at this point.
Okay,
I just thought it'd be a day-by-day thing, but I was wrong.
Okay. So, definition of even, one more time. If f of negative x equals f of x. Definition of odd, if f of negative x equals negative f of x. Any function that satisfies either of these criteria, you give this name to it. So, as an example, f of x equals the 0 function is one that can be both even and odd. How is that? Well, so what if I plug in a negative x into that function? What do I get? That happens to be the same thing as plugging in the positive x. So whether you're plugging in a positive or negative x, you're getting the same output. That makes it even. So this right there implies it's even. That's fairly odd. How is it that it can be odd? Any ideas how you can show that in fact it's odd? I mean, I agree. This is the. Chris, are you having fun there, buddy?
You see mine?
So how do you show it's odd? So f of negative x equal what? Well, it's equal to 0, right? Because that's what it says right here. For any input, you get 0. But isn't that also equal to negative of 0?
Dang.
And so that's the negative of f of x.
That's cool.
That's why it's odd. Okay, good. Good question. Any last questions before you have to put a grade on?
So Dale, do you want a grade for 1.1 and 0.2, or just one for both?
I think one for each one of them. That's a good idea. Good question. I'm going to say let's make a decision. A grade for each. How we get 1 point.
What do you say?
So one grade for each
Grade
section.
for section 1 and a grade for section 2. Put your names on it. I will. I'll glance through it myself and just for the most part, I'm going to write down what you maybe unless I feel like you just. Oh yeah. And I'm not checking this for correctness. You should be checking the odd one for correctness yourself. Answering back and forth.
So you want me to go ahead and take it up now?
I think for several. I think we're ready to turn it up. Okay. Well,
One question, if they got it in a notebook, do they need to tear it out or can they just leave it in that check?
that's a good question too. If you're in a spiral bound notebook, what do you do?
I mean, they can just bring it up after class and I can check over it real quick.
That's fine. We can do that. Yeah, we can do that here. Cause I was gonna collect them. We can look at it after class.
I mean, I can collect them now and do it during class if you want.
That's tell you what, we'll do the same thing. I'll just, if you have a minute after class, shoot in the spiral bound. You don't want to tear that out. I'll keep it got it graded. So we'll do that. That's fine. The ones that have it listed, I'll just collect. The ones that have it spiral bound, like you said, it's a good suggestion. I'll just look at it after class.
Dang.
So what would you give it? I just did everything for a summer book. For both or just one?
Okay, so now we're to section 3. And it's funny, that's that right there. That's right on the first day. That's the dead zone. I gotta stay back here. Not this. Okay, so we're on section 3 now. We'll play that same game again. Problem 1. Problem 2. This chapter, in summary, what would you say this section? In summary, what would you this whole section 3 is about?
I can't go home until like 4:30 today.
What was the question?
What is?
The question was, if you were to summarize what this section was about, like name 2 or 3 topics or something about this section. I heard algebraic functions. That's the big picture, absolutely. That covers the whole section. Within algebraic functions, what did you cover?
You got polynomials.
Yeah.
Polynomials, absolute value,
Rational.
rational. That's the ones I remember seeing here. Okay, good. You're familiar, were you already familiar with the definition of absolute value as a piecewise function rather than as simply make it positive?
Yes.
That's important enough for us to know going forward. That function definition is useful in that it's programmable because a function is not just always make it positive. Always make it positive is fine in some situations, but there are times when you need a function that's modeled as an absolute value, and having a functional definition is useful. Okay, so let's look at that problem one. We'll go again. Anyone want to volunteer to step off first? Okay, Jacob, fantastic.
Short policy. Sum of any two algebraic function is itself an algebraic.
Hang on a second. Did y'all hear Jacob read that at DCC?
I can read it.
Read it again. Try to read it a little bit louder.
Okay. Sure or false, the sum of any two algebraic functions is itself an algebraic function. Absolutely true, because the definition says a function is algebraic. It can be expressed in terms of constants and variable x by using only arithmetic operations, addition, subtraction, division, multiplication.
Exactly. So if you have two algebraic functions, meaning they're composed of those operations, and you add them together, then clearly you haven't changed the type of operations used, so you still have an algebraic function. So that's exactly a good reference to the definition there as well. So 1B, volunteer to take a swing at 1B. Oh, you want to take 1B for us, please?
Sure. True or false? Every power function is a polynomial function. And I said false.
Okay.
And
I
think I said, because when you look at like exponential functions, they're power functions, I think, but they're not polynomial functions, I think. Not really sure.
Yes, exponential functions are not polynomial, but exponential functions are not power functions either. Okay? So, a power function is something of the form a times x to the k, where a is a real number, k is a rational number. So this is real, this is rational. Versus a polynomial is the sum of terms a x to the n, where a is real, but n is natural. So that means 1, 2, 3, 4, etc. So notice the distinction between power and polynomial, first of all. So power can't be, not all power functions are polynomial because why? That was the question, right? So every power function is a polynomial function. So based on this definition right here, why is it that not all power functions are polynomial? What do you see different in the definitions? Can you give me an example?
Well, for polynomials, the exponent has to be natural, and in power functions, the exponent has to be rational.
Correct. So a power function example might be 3x to the 4/3. That can't be polynomial because it doesn't satisfy this. Well, let me ask you a question. Is every polynomial, so this is a follow-up, then I go back to the suggested answer. Talk about exponential, we have to mention that now. Follow up on this. So is every polynomial function power function? Well, only if it's a one-term polynomial. If it's a one-term polynomial, it's a sum of them. But if it's a one-term polynomial, then it is in fact power, because why? Can you view a natural number like number 3 as a rational number? So yeah, that makes it power if it's a one-term polynomial. Now, what about exponential? What does exponential have? And that's actually the next section that we have covered. Like a times b to the x. We have constraints on that. A is a member of the real numbers, and b, so that needs to be a positive real number. So it's an element of 0 to infinity. Technically, it should be excluding 1. So 0 to 1, union 1 to. So that's exponential. That's very different than these two because of the location of the variable. Excuse me, x. Okay, so that it is false. I agree. It's false because power functions can have fractional exponents while polynomial cannot. Okay, C. Volunteer for C. Emily, you want to take C for us, please?
Sure. Every polynomial function is a rational function, and I said that was true.
So that's true, okay. So how can I it as rational?
What was the question again?
Well, okay, so what's the definition of a rational function? I guess that's where we start.
A rational function is a function that can be written as of two polynomial functions.
Yes. So I'm going to erase the exponential because that's not really until next section. So rational is essentially polynomial over polynomial. I could better be a little more precise. F of x over g of x with g of x not equal to 0. But they're polynomials, that's correct. So how can I see polynomial function as a rational function? Polynomial is a sum of terms that looks like this. A rational function is a ratio of two polynomials. And the question is, how can I see something that's a sum of terms like that look like a ratio of two functions? I agree that's true, but how can I see that? Essentially answered the question earlier, or some people recognize it. Can you see the number of 3 as a fraction? How do you see it as a fraction?
3 over 1.
3 over 1. So can you see, if I wanted to see a polynomial as a rational function, how would I have to write it?
Yeah,
And then there's over
You had and you had g of x equals 1, right? So it's always 1, then you would have this being seen as rational. So that's why it's true. You could let g of x be 1. I'm not sure why I would want to do that, but it is possible. Okay, how about d? Here. Take the Izzy, you would volunteer for us?
Yes, okay, so D, true or false. For any real numbers a and b, the polynomial function f of x equals x to the fourth minus ax cubed plus bx plus 7 has exactly 4 real roots. And I got false for that. And if you plug it into a calculator and start using different values for a and b, you will see that not every single value of a and b will give you 4 real roots. They have to be above a certain threshold for the equation to have 4 real roots.
Correct. It could, and it has to be, you're right. I'm even thinking just, and that's a perfect example of using your technology and trying it out. Fantastic. Simple counterexample, also just mentally. What if a and b are both 0? It says any real numbers a and b. So what if a and b were both 0? Just mentally. What function do you now get?
X to the fourth, 7.
You have a quartic.
Oh, yeah, right? Yes. It was quartic before. Now you just get x to the fourth plus 7, right? It simplifies to x to the fourth plus 7. What do you know about that? It's quartic, and it's x to the fourth plus 7. So does that have any real solutions to it?
It's going to be in there.
Well, now the answer would be no, right? Because you'd be like x to the fourth equals negative 7. So that one wouldn't have any real solution. So there's just one quick, simple example. But certainly you could try all kinds of different numbers and see that there is some values, set of values that will get you there, but not all of them. Okay, what about 1e? Let's go and take that one first.
True or false? If f is a polynomial function with k real roots, then the degree of f will be at most k.
That's true. Think it's true? Oh, the audience. What's the audience say? Since I responded that way, probably since it's either true or false, I'm going to guess it's either false. Why is it false? Let's look back in the definitions of the theorems. Back to on page 37, the theorem says f is a polynomial function of degree n, and the graph of f has at most n real roots. Think about how that's written. If the degree is n, then the number of roots is at most n. That's the opposite of the question. The question says, if a polynomial function has k real roots, then the degree must be at most k. With k, the degree can be bigger than the number of roots. So it's actually the opposite. So they snuck that one in on. So the answer is false because it needs to be at least, if it had been at least k in this statement, problem. Want to follow along? We're a little sneaky on the wording there. Okay, how about 1F? Volunteer? What's Sandy?
True or false? If f is a polynomial function with k turning points, then the degree of f must be at least k plus 1. And I put true because the book said that if the degree is k, then there has to be k minus 1 turning points, and this is just the reverse way of saying that.
Exactly. That's exactly right. That's a reference directly back to the theorem. Good. How about G? Volunteer for G.
Okay.
Razor wants to go again. Uh-oh, he wants is that a question or a volunteer?
I was volunteering.
Fantastic. Go again. He wants promotion from corporal to sergeant.
Oh boy. Alright, so letter G.
Yes.
True or false? A rational function is a quotient of two polynomials. Is it me? Did you say me? Am I right?
Yes, keep
Okay,
going.
okay. Where the denominator polynomial is not the zero polynomial. And I said true. Because it's, it's like P of x over Q of x or whatever the thing was. And if the denominator is zero, then it can't work.
That's exactly right. Yeah, that's pretty much precisely the definition of a polynomial function. Okay, how about H? Other volunteers willing to volunteer for us? Dylan, you want to volunteer?
Sure.
Okay.
Let me another question. True or false? Every rational function has a horizontal asymptote. I said that was, false.
Good.
Why?
Can you give an example that does not have a horizontal asymptote?
So, y equals x is a root, right? Like that could be a root.
Y equals x?
Yeah.
Yeah, I'll go with that, sure. Excellent example. Okay. So, y equals x. Is that a rational function?
Good job.
Yeah, so you don't have a horizontal asymptote with that.
Sounds like f of x yesterday.
You can view this as y equals function x over function 1, so that makes it rational. And clearly that doesn't have a horizontal asymptote. Okay, good.
You got him, Dylan.
Next book mentions in theorem 18 on page 39, talks about horizontal asymptotes, and part D says if the numerator is bigger than the degree of the denominator, then the graph does not have any horizontal asymptotes. So in the example that Dylan provided, what's the degree of the numerator?
Good job.
That's 1. What's the degree of the denominator? 0. Is that bigger? 1 bigger than 0, so yes, it does not have a horizontal asymptote. That would be true if it was a less case model of rational function. Okay, good. What other questions have you heard with? There were concepts. There were a couple good questions on post. I know Razor had a question about holes. I mean, it's all about knowing your asymptote from a hole in the graph. Right? Okay, so did the explanation about holes in the graph make sense? Sure. And asymptotes. Did you see the post about that? Okay, good. what other questions did you run against? Any questions that you're like, oh, I don't know?
I have a question.
Question, yes. Brittany?
What's gonna be on our test? Is it just
What's
like
going
an
on?
overview?
Well, your test is gonna come from problems in the book this time.
So is it like practice problems that are in the book but slightly changed, or is it like the concepts that we are learning about?
Fair question.
Well, honestly, this time, since it's review of pre-calculus, it's just going to be take problems out of the book and maybe change a number or something like that. I'm not going to make up my own test. This is going to be just a pretty straight up test. Future test, however, when we get into calculus, I'll write my own test, and they will be probably a little different in terms of. Not everything will be exactly right out of the book. Some problems will be like out of the book. Other problems will be more conceptual, explaining type of problems, as well as application. This practice we've been doing on explaining is actually quite important. See that on this test. I'm just going to pick problems, do something like that on this test. Kyle, you got a question?
Will the rest of the class be structured like how it has been this week, where we go home and do the work on the problems and then just come in and ask questions?
After this chapter, when we start doing new material, my plan is to try to introduce material first and then let you practice at home.
So it'll be more like a traditional classroom?
Like a traditional class.
Okay,
Since
cool.
this was review, I felt that it was good for you to try to climb that wall on your own a couple times and see how you do. Since it's review of pre-calculus. Brittany, you still have another question?
I have a question on the homework. I was wondering if we could
Fantastic.
go 17B.
Before we do that, are we all clarified on the test? The test is Tuesday in class, and it'll be paper and pencil.
Oh yeah, I have another question.
Yes. Chris.
Will the test use like a syntax or like a wording that's similar to the one in the textbook?
In the book.
Yes.
Okay.
Yes.
Okay. Dang it. It's all confusing.
Another question. I look at it. Yes. Go.
Yeah, will you be grading the test?
Or will
Yes.
Yes, I'll be grading. I'll be grading the test. I'm going to ask Stinger to scan your test to me, and then I'll grade.
Will there be partial credit on the questions, or is it just right or wrong?
Yes, I grade on partial credits. So I try to assign the credit based on how well you understood the concept that the question is getting after. If you make a mistake and say that 3 plus 2 is 6 because it happens to be Tuesday, I probably won't take off full credit, maybe 1 point. But if you have no idea what the concept is and you're just like off in left field, you're probably not going to get much credit at all. Does that make sense?
Yes, thank you.
I can do it.
It usually is actually beneficial. The grades are usually better, a little better by doing partial that way. On the other hand, I'll say this. To me, partial credit is a two-way street. So if I see an answer that looks like it's really quite right, but the work that goes with it has no relation to the answer you got, then you're not going to get full credit for that either. That make sense? Okay. Any more questions about the test? I would expect about 10 and 15 problems.
Okay.
Oh yeah, I have a question.
No,
Actually, he may have,
yes.
you may have already answered this, but it's a pretty short question. When is our first test gonna be?
Turn around and ask the last Someone illuminate us on when the first test is going to be?
Tuesday.
Okay, thanks. I'm sorry I even asked.
And one more thing, I don't know what your schedules are like. I typically allow on an 8 o'clock class like this, I allow my students to come in early to have more time on the test if they would like. So I'm willing to allow you to start, say, 15 minutes early. Are you all in this class able to do that if you like? DCCC, are you able to do that if you'd like?
Could we stay late instead of starting early? Could we get start on time and get...
This cleaner's not gonna want to stay.
We can accommodate that. We can let you go 15 minutes late instead of starting 6 minutes late. That will work better for you.
It's wonderful.
Thank you.
That depends on Ms. Cleaner, though. If Ms. Cleaner can stay there with you for the extra 15 minutes after, that's fine.
That works.
Yay!
Okay, I know this is like a really
No, I can't.
question.
No, we actually don't. It's not 9:30.
Oh, 10:15.
But we do have to end at 9:30.
Yeah, we have another class at that. So you can come in. We'll make it up. Okay. Other question. What was? I'm sorry, Brittany. You had a question about which one was it? I got sidetracked.
17B.
17B. Suppose f is a rational function with roots at x equals 1, 3, a whole at x equals -1, a vertical asymptote at x equals 2, and a horizontal asymptote at y equals -1. Sketch 3 possible graphs. Well, you did ask about that. Write down the equations of the 3 functions and how they give the properties. Oh my gosh. This will take a while. Okay. Hold on.
Why are they all so long?
Now let's think our way through this. 3 of them. 3 plus. Okay, so we have f of 1 has to equal 0, and f of 3 has to be equal to 0. And in terms of rational, let's say that rational is p of x for the numerator and d of x for the denominator. So
Bless you.
that means for this to happen, this is equal to f of x. So in order for f of 1 to be 0 and f of 3 to be 0, what does that mean over here for n and d? So yeah, this means these two statements here that n of 1 equals 0 and n of 3 equals 0, but d of 1 is not equal to 0 and d of 3.
Okay.
Well, so a whole at x equals -1. So f of -1 equals does not exist. But in particular, it's a whole. So what does that mean about this? What's going to happen in terms of the numerator and denominator for that to occur?
Doesn't it mean that -1 will be a root for both functions?
Correct. -1 is a root for both functions. So n of -1 equals 0 and d of -1. You have a vertical asymptote at x equals So f of 2 is non-existent as well. But this time it's an asymptote. So, but what has to occur to cause that? And that, again, this was in the post last night. We read that. Kind of restrict what's happening with in terms of these two functions here. What's happening? Okay, the main issue, and this time we would have d of 2 is equal to 0, but n of 2 is not. Well, let's see what else we got. Horizontal asymptote y equals -1. So f of x goes to -1 as x goes to plus minus. That's the information out there.
Okay.
What does that mean about this stuff? These are the criteria I have to satisfy. What does that mean in terms of this? We just talked about that. That was one of the true false questions. As a horizontal asymptote, what did that theorem say if it's a horizontal asymptote?
It is a horizontal asymptote.
Well, because it's not, the horizontal asymptote isn't at y equals 0, then the two degrees of both functions are equal.
That is correct. Excellent. Yes. So the degree of n is equal to the degree of p. Excellent. Yes, excellent. Okay, well, let's make a graph. How do we make a graph out of that? Can you see all that on the board, on the screen?
Yes.
Oh, that's important. What can we put on here?
Well, what's it doing?
Know what?
You could draw your asymptotes first.
Excellent suggestion. Let's do that. So we have what?
Y equals. Oh yeah, you can do the vertical ones if you want. It's your graph.
Well, it doesn't matter. We can do the vertical one first or the horizontal one.
To each his own.
These different graphs. I'm not sure about that. Okay, so now what? We have what's happening at -1?
What? You have a hole.
I have a hole in it there somewhere. So, okay, how about let's go hole up there. All right. Gotta have, what else? What are other information? I just randomly picked with that hole in. Oh, roots at 1 and 3. Okay, so that means we've got a point there, and a point there. 1, 3.
Let's go and touch.
I'm trying to write a function for that. I don't know, but I guess I could sketch something for this. If I had, with this, the way I've got this set up, I guess I could sketch something like this.
He's crossing an asymptote. That's deep. Well, you can do it with horizontal ones. You can't do it with vertical. What's the point of a horizontal asymptote if you can just cross it? It's meaningless. There's no point to it.
I would. That's not a correct statement. It is actually meaningful, and it's not the same thing as vertical asymptote. Once again, a vertical asymptote has to do with a domain issue. That means you're causing the denominator to be 0, and not the numerator. That means that number cannot be, 2 cannot ever be in the domain. So I cannot ever touch that 50,000 volt wire. Ever. However, the horizontal asymptote is not what's going on in the middle. Vertical asymptote is what's going on kind of in the middle of the graph. When x is 2 or x is 3 or whatever. Horizontal asymptote is all about what's going on when x goes to infinity. So what's going on in here has nothing to do with that horizontal asymptote. I can erase it. It only really comes into effect when x goes to infinity. So in fact, before you get to infinity, you can cross that horizontal asymptote a bunch of times. It won't. Yes, that rule you heard in high school, you never cross an asymptote, is only true for vertical asymptote. Horizontal. So that's a little bit of an imprecise statement. Okay, so there's a function graph. Writing a function for that. I'm going to stick with 1. I think that's enough. 3, 4. I mean, if I want to do 3, I've got to keep these two roots the same. The only thing I could visualize doing differently than this one to get a different graph is the hole might not be there. It just says it has to be at x equals -1 has to be a hole. But unlike the roots that say it has to have a y value of 0, it doesn't specify where the y value is for that hole, so I might have put the hole up there. Well, now what do you got? I don't know. Maybe this one looks like question. And of course, in the no, it's still got. I can't do that. Why is that not a good graph? Why did I do wrong there?
The root.
That red graph. I didn't cross the axis at the correct place. So I didn't do that graph right. This would have to be that, and then the right hand would still be the same as that.
Oh, that's clever. Yeah, I like it.
So that time, I crossed the horizontal asymptote once again, right there. So that'd be a different picture right there. A third picture.
That's awesome.
So now we're going for equation.
Yeah, I guess the third case, you're right. I could put it between the horizontal and the axis. I could put it right there. Then let's see, what would I have? An asymptote. Maybe I would come up. I can't cross the axis, but I could maybe touch it and then come down, and then this would still be the same. Okay, so there's 3 distinctly different graphs that satisfy this criteria. Writing functions, let's see. How do we cause n of x to be 0 when it's 1 or 3? What are we going to have for that? We could have like a factor that says x minus 1 and a factor that says x minus 3.
Yeah.
Good. What do we got? But what does that also tell you about the denominator? That's a root. What does it tell you about the denominator? The denominator cannot include either of these factors.
No, that's right.
So what about this next one? F of -1 is a whole.
It's a whole.
So both the
Make a whole.
numerator there have to have the
X
root.
plus 1.
I'm sorry. Raise your hand for speaking of these. I can't tell. Chloe, okay, Chloe. Go ahead.
That means that both the numerator and the denominator have to have the root of x plus 1.
Correct. So we need an x plus 1 in both the numerator and denominator to create that whole.
Got
What else do we have? We have an asymptote at 2. What is it required to make an asymptote, vertical asymptote at 2? X equals 2. I think it's not good. It's Josh. Josh, yes. Go ahead.
Put the x minus 2 in parentheses in the denominator.
Yes. And we put an x minus 2 in the numerator with that. Could I if I wanted to?
Could you?
No.
Could you?
No, because then it would
They
create a
cancel
whole.
out.
Could you?
It would be a whole.
Yes, I heard someone say, if I put an x minus 2 in the numerator, who was that? Is that Sammy? Or would you say, Sammy, if I put an x minus 2 in the numerator as well as the denominator, what's that going to cause?
A whole.
Whole. I'm not going to put an x minus 2 up there. Let's see, what else we got? It says that the y values get close to -1 as the x values get close to infinity. That's identifying a horizontal asymptote at -1. What does that mean? What do we say? Degrees have to be equal.
Yes.
How do we make that happen? Are the degrees equal right now?
No.
How do we make them equal?
Could you just throw another X on the bottom?
4. Let's throw another x on the bottom.
Yay. Could you square X minus 2? No, don't. Why? What if I want
So
to?
what happened? Be careful. What happened by putting an x on the bottom there? Let's stop and think for a minute. I followed what you said. Next. What did that do? Made it a degree 3. I agree with you. That's good. But what else did it do?
Made a second asymptote.
What
Now
did it
have a root at 0 in the denominator, which causes what to happen?
do? Caused what to happen?
That factor that everyone wanted me to put in, and I said, sure, let's put it in. Good. Now we have a degree 3. That makes our horizontal asymptote -1. You're absolutely right, but you changed something else when you did that. What did you change? Joe, you just said it. I now have a root at 0 in the denominator. What does that change in terms of the graph?
What does it change? What does it change? What is it? Dang it.
Let's back up. Where and why did you decide to put an x minus 2 in right there? Why did you just randomly say, let's put an x minus 2 there? Somebody said it, and I said, okay, sure.
Vertical asymptote.
Vertical
Who said x minus 2? Own up to it. X minus 2. Who said it? Somebody said it. I think it was Josh. Josh said, put an x minus 2 there because we need a factor. Why did you say that, Josh?
Make an asymptote at x
Good.
equals 2.
Now, Josh, what's going to happen by putting an x in the denominator?
It'll make an asymptote at x equals 0?
Yes. Do we want an asymptote of x equals 0?
No.
So is this going to be a good thing to do?
No. Was I right when I said square x minus 2? Yay.
Let's try that. Let's try maybe squaring minus 2. Okay.
Why am I getting this so right? This is dumb. This is dumb. No, that's all right.
Okay. Now the only other thing, if you wanted to write 3 different functions, you probably need like a point on the graph that you can plug in and find out like the coefficient or something like that. Honestly, I'm going to stop there. I'm not. I promise on the test you won't have to make up 3 different functions.
Yay.
We're at 4 minutes. Okay. Time flies. Did that answer your question? I mean, I didn't really completely answer your question. Did it sort of answer your question?
Yeah.
Police never made it in, did you? Couldn't answer. We've got 4 minutes. We have time for maybe one more question. Josh. Oh, thank you, Josh. Josh, yes.
Question on the 17b again. What would happen if you made that equation negative? Are you supposed to or need to? The equation we just
could have. Let's see. Could you have made it negative? You mean like put a negative sign in front like this? Is that what you mean?
Yes.
Yes. Yes, and that was something I didn't really go through all the details with, but when I said something a moment ago about calculating a coefficient like A in front of the whole thing, A could be -1, A could be 17. What affects that coefficient is how stretched out it is, or if, like you are indicating, maybe a reciprocal picture, inverse image.
That's cool.
So if I wanted to make 3 different ones, I could just say, well, let's call that number 0, 5, and I can work with that up here and figure out what A is. I know that at x equals 0, y is equal to 5, and I ought to be able to back into what A is. I have one that's at -1/2. So if I know at x equals 0, y is equal to -1/2, I can plug in zeros for x's and -1/2 for y, and I can solve for x. Does that answer your question? So I can also use -1. I could just put -1 and then try to figure out how that would affect the graph above. Does that answer your question?
Yeah.
Okay. Well, last section is section 4 for Monday, so finish up section 3 if you didn't get a chance to finish it. Work on section 4. How we're doing. Monday.
Amanda.
Yes.
Can Kyle have a question or construction?
Yes. Is there a way that we can get the answers for section 1 and 2 posted on Moodle so we can check ourselves and review for, is that not a thing?
Well, not really. There's all the audience are in the back of the book, so you should be able to check yourself at the top.
I'm gonna try something with our overhead projector. See if we can have access to the middle whiteboard. So can you stay for just a minute after the students dismiss so we can test it?
Sure.
Okay, thank you.
Okay, y'all have a good weekend. See you on Monday morning.
Miss Cleaner, did you ever respond about my accommodation? Okay, thanks. I'm sure he's working on it. I'll send him another email today. Kyle, I need to get you the print off of the solution.
So is there anything that we can do? You gotta be able to do it.
That's not. That'll give us 3 points. You have to tell me when you're going to use the code. I have to get it.
Yeah, I feel like our pictures are
You do the lab if you're not wearing pants to do
That's actually really cool.
So right there, so like this, instead of checking all there for us,
Math tutor hours.
now we have access to the middle board.
I don't.
I want to send this to Cody.
Well,
It shows up.
basically an hour after our class.
Yeah, so that
Okay,
makes
so,
That's fine.
so that way, I turn off the overhead and remove it from the screen. This is what you're seeing. This is what they're showing. Okay, and I do this. Now have 3 whiteboards as opposed to 2. Is that better?
Yeah, that'll be all.
So, because I was just trying to figure out how we could maximize, because that board's not being used at all. Okay. Amanda, what we did was we eliminated the overhead projector. And so, from your point of view, does it look any different at all from what we're projecting?
Not really.
Okay, good. That's what I wanted. I wanted no difference. Okay. So, and if I flip you here to start showing the podium, you can now see what the tablet on the podium is projecting. Do you see that? It's got the x equals x plus 1.
Uh-huh.
Okay, just making sure that it's working the way I hoped, okay?
Okay.
Okay, good, perfect. All right, okay, I'm just trying to use the real estate of the whiteboards in the room more efficiently, okay?
Okay.
Okay, good. It's exactly what I wanted to happen, okay?
Fantastic.
Okay, good. Yeah. Well, where are those?
What
Okay.
section?
What we just did, he went over something else. It was like
White
the
switch of the billion stuff they have in here.
rational function thing. He was like, you just put a 1 underneath it.
Yeah, so like, let me show you.
Okay, good.
Like rational function.
They got the same or similar switches over here.
Yeah, I think those do the.
Is it just like a 3-way?
Is it like my kitchen where both have to be up?
It's a 3-way.
Be written as a fraction where this is not equal to 0, and that makes it rational. And so basically what he said is that, well, if this equals whatever it was, and
There you go, we got it, we got it.
if this equals 1, then you have a rational function.
One that
Basically,
turn
it's
down.
written as a rational function if this is 1.
I got both
But
fingers
that's
all
still
the
a
way.
function. Because it passes the
Now,
vertical line.
I keep turning the other ones out, but that's right. So now what's
Yeah,
it look
because you
like?
can write 1.
So all polynomial functions.
Yes.
Is this,
Yeah. You can do this,
if
basically.
we figured out the light switch,
All this technology,
you
to
know,
figure out how to
figure out the
light
light
switch.
switch is fine.
Alright, thanks.
Is that brighter than it was before?
Does that look better now on the screen, the whiteboard? Is it more visible?
It looks similar enough that it's almost the same.
But AD, so if there is with it, there is without it.
Okay, that's without the lights on. That's with the light on. Is either
Doesn't
one any
really
better?
change.
No speaker.
No.
Yeah.
What
It
if
doesn't
we-
really change that much.
Okay.
I was gonna say fade it down a little bit.
But that's just the camera refocusing because of the lack of light. But from our students' perspective, with the lights, it's a little bit easier.
Probably is.
Yeah. So there's no change on theirs.
Fortunately, the way they're set, that. I should have put a shadow right in the center of the board.
It makes Dale look a little more vibrant.
Okay, well, that's all that we need. Okay, good. Perfect. Thank you so much for your time. I appreciate it.
Yeah, no
I'm
problem.
gonna disconnect now.
We need one.
Okay. Bye, Dale.